issue from the perspective of the global internet. Okay, large-scale DDoS or a global worm epidemic is everybody's concern, but port scan is between two individual hosts, so it's it's a little bit minor problem. About this DOS with the variable port. Well, when we started, we sort of split these two types of DOS attacks. But if you come think about it, I mean, you don't have to do that actually. DOS with variable port, DOS with fixed port, doesn't matter. Okay, they are all DOSes. Okay, so if you sort of remove that this distinction, then the relative error for the DOS attacks with variable port numbers goes down. Okay, so that's how we solve this problem. Okay, we later we found that after we published this paper. Okay, so the false positive rate quickly goes down to almost zero after the attack rate goes over the threshold, and it remains so. Okay, so it has good properties too. So we sort of get the idea from the visualization work about the algorithm that can quickly extract only the attacks from the high-speed flows, high-speed pipes, and how to classify them in real time and how to calibrate the intensities of them. And so that's the second part. Okay, the third part is the recent developments. So I stopped this work like 2 years ago, but my colleague Professor Hee-Jo Lee, who was a visitor here a few years back, is extending this work, and he calls this parallel coordinate attack visualization. Why parallel coordinates? Because I use 3 dimensions, okay? And using 3 dimensions, it has some shortcomings. And he thought that using some more values from the packet headers, he can even he could lower the false positive probability and errors further. So he decided to use some other values from TCP/IP headers, like IP datagram length and TCP flags. And also he moved from packet-based operation to flow-based operation, because he thought that it's quite difficult to plug in the software to a router port directly. Rather, he chose this approach that gets the flow information from like Cisco routers, okay, and operate on that flow information instead. So he improved the scalability in that sense. So it's the system that he's designing. He actually implemented it, by the way. So you call these guys that generate flow information sensors, and in this version of the software, he gets net flow input from these sensors, and the monitoring system sort of combines those net flow information and. But the core engine is similar. Okay, it basically works on this, what attack signatures, and see if there is any attack. But since he extended the dimensions to 4 or more, basically hyperspace, you cannot draw the 3D space diagram like that. The thing that we saw earlier. So he uses parallel coordinates. So a single flow appears as a line here. Like before, legitimate flow is a single line, but attacks appear as a different shape. Okay, so for a slammer attack, from the slammer attack trace, he got this, the first one. From host scans, you got this, and so on. So he made the signatures similar to mine. And actually, let's see how his system works. Okay, so So on the top, using this plotting method, he plots entire flows. Among them, there are attack flows hidden in there, and he uses his signature to extract the attacks here. And if you see a particular pattern, then it's an attack, and the attack information appears on the right pane. Okay. So it goes like that. And if you want, you can click on a flow to see the detailed information about that attack. Okay, where it's coming from, and basically the source addresses and the number of packets observed in a given unit time, and so on and so forth. So he has this this graphical interface. I didn't have one, but he has. Yes. So, I guess this is the end of it. So, to summarize, what we saw is that you can actually visualize your text in a single space, in a single framework. You can see all kinds of attacks working in that 3D space, and you can actually get an idea from how the pictures are drawn in that space, and using that idea you can devise an algorithm that efficiently extracts the attacks from the traffic stream and classify them and measure them and visualize them for the convenience of the network operators. And I guess that's it. Okay. So I think I have like 5 minutes, so if you have any questions, I can answer them.
Any questions? For the kamikaze attack that you mentioned, which you conjectured would be actually backscatter packets, can it not be perhaps verified by checking if there was
Yeah,
a
actually.
attack?
That's right.
Okay.
Yeah, actually, last night I was going through my slides, and then I found that actually I had the same question. I didn't have that question 2 years before, but 2 years ago, but. And then I tried to log into my old system and run the software again, but I failed. I forgot a lot of details about running the software and stuff, and I couldn't find the right trace where it was, so I couldn't check that. But actually, if you see in the same time frame, if you see a DOS attack, you can check the destination of that DOS attack with the source of this kamikaze stuff, and if they match, it's a reflected image of that DOS. But I couldn't check whether they match. But if you see, there's a few DOS attacks ongoing at that moment. Actually. So if you see, this is one DOS attack, and I know that because it's using this is the class D, class E space. You cannot send a packet to class D, class E space. Class E is reserved for future use, so it's not being used right now. So if you see packets are being sent to that space, you can immediately realize that it's an attack. So it's a DOS attack. So this kamikaze could be paired with that, but I couldn't